Next we have boy fly the kite. So for sure the boy is on the ground, right? And he's flying a kite. Let's say his kite is somewhere here. Let's say K, and the boy is standing here. So this one will label it as point of observation O. He noticed the angle of elevation of the kite to be 30 degrees. So since the boy is here, kite is above, right? This will be the angle of elevation 30 degree. Keeping the kite in the position, he moves such a way that the angle of elevation changes to 45 degrees. So we want to increase the angle. So angle will increase when the boy goes little ahead. So here you can say now the angle is 45 degree. So this is the new position. Let's say O2. So drawing a perpendicular on the ground, right? We have drawn 90 degree on the ground. Let's say this point is P. So here you have two right angle triangles. One is this one, right? KO2P. KO2P is one right angle triangle, and another one is KO1P. Triangle KO1P is another right angle triangle. So using these two right angle triangles, you can solve the question further. Let's move on to the next question. Question number 5. An observer on the ground noticed that angle of elevation of aeroplane, right? Observer is on the ground. So again the same situation. Draw the ground. So let's say this is the ground and somewhere here is the observer. Such type of dashed lines should be shown in order to represent a hard surface, ground. So observer on the ground notice the angle of elevation of the aeroplane. So angle of elevation of the aeroplane, let's say aeroplane is here, O, point of observation O, changes from 45 degree to 60 degree in 15 minutes. So let's say this was the 45 degree and it got changed to 60 degree. 60 degree means slightly a bigger angle. So the angle of elevation is now, the aeroplane was first here and now it is here, and this much the time taken is 15 minutes. So this will be the diagram. This is the 60 degree. So learn to draw the diagram representing the situation diagrammatically is a key to learn science. So observer on the ground notice the angle of elevation to be 45 degree. He then notices that angle of elevation changes from 45 to 60 degree within 15 minutes. So aeroplane has traveled from A1 to A2 in 15 minutes. So in such questions you may be asked to find the speed of the aeroplane, right? You may be asked to find the distance. If the speed is given, you can calculate the distance. So once again drawing perpendicular from A1, right? So let's say this is the point P. So this is one triangle A1 OP, and then you'll have one more triangle here, right? Let's say this is Q. So A2 QO is another right angle triangle, right? So from these triangles you can do the required calculations. The next, from the top of the tower A, the angle of elevation and depression of the tower is 30 degree and 45 degree respectively. So once again from the top of a tower, so for sure the tower is on the ground. So let's say here we have a tower, right? So tower A it is. So you can label it. It looks good if it is labeled tower A from the top. So here is the point of observation O. The angle of elevation and depression of the tower B. So elevation they have asked. So with respect to horizontal and above. So tower B, its top must be somewhere here. In this question, to identify which one is bigger, A or B, don't do mistake. Just start from the question from top of the tower A. So point of observation is here, and they have said elevation. So when you are looking above, for sure the tower B, its height is somewhere above the O. So this is the angle of elevation. It is given as 30 degree. And also the depression when I see the bottom of the tower. So bottom of the tower with the horizontal and downwards, right? 60 degree with horizontal and downwards. These rules you must remember very well. It will help you to get a grip on the content, this chapter, drawing diagrams. So here you have those rules. Fine. So situation, then right angle triangle formation. Now here you can see the right angles. This will be the one right angle triangle. This is the one right angle triangle, right? O, let's say P, Q, R, S. So O, Q, P is one right angle triangle. We have right angle over here. Then we have O, Q, R as a right angle triangle. We have 90 degree over here, right? This is one more right angle triangle, OSR. So from these multiple triangles, you will be asked to find the distance between the towers, height of the tower A or height of the tower B. You can do calculations. So once you draw the figure, your sum is more than half done. The next one, we have an observer observes the angle of elevation of the two towers on his two sides to be 60 degree and 30 degree. So angle of elevation of the two towers on his two sides, 60 degree and 30 degree. So let's say observer is somewhere here. This is the ground, and let's say observer is here, O. Or take like little bigger space and draw a bigger diagram. It will help you to understand the situation much better. The smaller diagrams, marking and so all, they get mixed up. So draw a little bigger diagram. Angle of elevation of the two towers on its two sides. So there is one tower on one side and another tower on other side. One of the tower elevation is 60 degrees. So let's say this one is 60 degree, right? And this one to be 30 degree. Since this is 30 degree, it should be little smaller, right? However, constructing the situation, it's okay, but understanding has to be there. This angle is large, so this must be a larger tower, right? Somewhat like this, small or bigger than the other tower, which is making a 30 degree. So this is the situation. Again, you can O, P, Q, R, S, right? Triangle ORS is one right angle triangle. You have right angle triangle over here. Then PQO is another right angle triangle. You have right angle over here. You can find out the distance between the towers or distance of the observer from the first tower, distance of observer from the second tower, height of the tower. You can calculate depending upon the question. Then next, eighth one, from the top of a high-rise building, an observer sees the angle of depression of rickshaw to be 30 degree, which changes to 60 degree in 20 seconds. So observer is on a high-rise building. The first line itself, it tells us that observer is on the high-rise building. So let's draw a building. So let's say this is the high-rise building and observer is here. So we'll label it as O. Right, sees the angle of depression of the rickshaw. Depression means horizontal and downward. So here will be the rickshaw, let's say R. Rickshaw to be 30 degree. The angle of depression was 30 degree, which changes to 60 degree in 20 seconds. So this angle of depression got changed to 60 degree. Now this is 60 degree. And the time taken to change the angle of depression was 20 seconds. So from position R1, rickshaw has traveled to position R2. You must be clearly able to see the right angle triangles, right? Let's say P, R1, R2. So triangle OP, R2 is one right angle triangle. Triangle OR, OP, R1 is another right angle triangle. Angle of depression, you should convert it into angle of elevation. It will make little easier. So this one is 60 degree and we'll have this one also as a 60 degree, alternate angles. So changing depression to the elevation, alternate angle is the relation which you must keep in mind, right? This line and this line are parallel. Either OR1 is a transversal or OR2 is a transversal. The ninth one, from the top of the fighter plane, enemy tank makes a depression of 60 degree. So fighter plane we have and an enemy tank we have, so we need ground as well as we need to be in the sky. So let's say fighter plane F is over here and it is making an angle of depression. So let's say enemy tank T is over here, right? From the top of the fighter plane, the word top, it can be replaced from inside, it's better. From inside a fighter plane, enemy tank makes a depression of 60 degree. So this depression is given as 60 degree, but ammunition can be fired only when depression changes to 30 degree. So plane can't fire at 60 degree, it can fire only when the angle is 30 degree. So to make the angle 30 degree, the fighter plane has to move forward, and now the angle of depression will be 30 degree. So this is the first position F1, this is the second position F2. It slows down for 15 seconds so that the angle of depression is 30 degrees. So slows down word does not hold any importance here. The important is 15 seconds. The plane has traveled from F1 to F2 in 15 seconds. So this is the situation, right? Enemy tank is at maybe target. So again you can construct the right angle triangle over here. This will be one right angle triangle. Tank is over here. Let's say this is P, this is Q, right? Convert the depressions into elevation. So this angle will be 60 degree and this angle will be 30 degree. So you have triangle F1P T, right? And you have another triangle F2Q T as a right angle triangle. So you can calculate many things, the height of the fighter plane, the distance, right? Next we have angle of elevation. Stop the video and try yourself, right? Then you can continue the video for the explanation. Angle of elevation from a mountain of a cloud. So we are on a mountain, right? Let's say here we have a mountain and we are on the top of the mountain. Angle of elevation they have said. So we are on the mountain, and elevation of a cloud. Elevation means horizontal and above. So let's say cloud is somewhere here. See, cloud in the sky is 30 degree. Angle of elevation is 30 degree, but its depression in the lake below. Depression in the lake below is 60 degrees. So there must be some water body over here, a lake. So its shadow falls over here. Its shadow falls over here, and this is the you can say shadow, right? Its shadow over is here. So we'll label it as S. So its depression in the lake is below 60 degrees. So this depression we have is 60 degrees. So once again we here have a right angle triangles, right? From the top of the mountain, clouded, its angle of elevation is 30 degree, and the depression of the cloud in the lake below. So for sure there must be some lake below the cloud, and its shadow falls into the lake and it is 60 degree. So here we can convert this 30 degree, which is the elevation, 60 degree, which is the depression, we can convert it into elevation. We'll have once again a right angle triangle. OCQ is a right angle triangle, OCQ. Then we have another OQS as a right angle triangle, and we also have a OPS as a right angle triangle. So now you must use your logic which triangle to use and to find what. The question may continue. These are the questions just to understand this. From the moving train, notice that angle of elevation of cloud. So there is a train which is moving, right? So let's say train is somewhere here. We'll take it as T1. Notice that the angle of elevation of the cloud is 30 degree, which changes from 30 to 60 degree. So angle of elevation of the cloud, let's say cloud is here, which was 30 degree, right? And let's say the train is moving in this direction, then only the angle of elevation can be increased. Sorry, it's wrong, not this way. Angle of elevation need to be increased, so we need to go to closer to the cloud. So train is moving here from T1, it has come to the T2, So now the angle of elevation is 60 degree. So once again you can draw the right angle triangle T1, T2, and let's say this is O. So triangle COT2, triangle COT1, these are the right angle triangles, right? So common 90 degree for both the triangles. You can do the calculations. Then 12th one, from a tower, depression of a foot of one of the tower is 30 degree and other is 60 degree. So from top of a tower, a little challenging question. So you are somewhere here and the depression of one tower is given 30 degree and depression of another tower is given as 60 degree. So horizontal line, this one, let's say, draw it and then mark the angles, right? So this confusion of which one will be bigger and smaller will get solved. So the smaller one will be the 30 degree, right? And this bigger one, it will be 60 degree. So depression of the two towers are given 30 degree and other is 60 degree. So we have drawn, this is, let's say this is the tower number 1 and this is the tower number 2. No elevation is given, so we don't have to worry about its height. Convert the depression into elevation 60 degree, this will be 30 degree. So let's say here is the point of observation OPQR. So you have a triangle OPQ, one right angle triangle, and other right angle triangle will be OPR. The same sum, one more way the diagram can be drawn. What is that? So let's say you are here, right? Angle of depressions are given. So from the horizontal and downward, so let is the depression of the tower 1 and depression of the tower 1 is 30 degree. And maybe the other tower is on the other side of the observer. Maybe it's not clear in the question whether towers are on the same side or towers are on the opposite sides. So let's say another tower T2 is here and its depression is 60 degree. So this is another diagram, right? Further, it may be given in the question about the position of the towers on the same side or on the other side. These are not complete questions, questions which will help you to draw the diagrams. Then question number 13, from the point on the ground, angle of elevation of one mountain A is 30 degree and other mountain B is 60 degree. So let's say this is the ground and here we have a point of observation O. These dashed lines are important, a scientific notation, so don't ignore. Angle of elevation of the mountain A. So let's say here is the mountain A and its elevation is 30 degree and we have other mountain B and its elevation is 60 degree. So let's say we have another mountain somewhere over here and its elevation is 60 degree. But this situation looks little unrealistic. Both the mountains should not be on the same side. How he will see the other mountain? So you can redraw it. You can say that this is the tower B, right, which has the angle of 60 degree, and there is another tower A, another mountain A which is smaller and it is making angle 30 degree, right? So this is the tower B and this is the mountain A. So this is how you can change the drawing. Let's read further. If the observer moves back 20 meter, the angle of elevation of two towers of two mountain are 40 degree and 10 degree. So if the observer is moving back 20 meters, so from here he has moved to the new position O2, O1 to O2. So now the angle of elevation is 40 degree and 10 degree. So for B the angle of elevation is now 40 degree and for A the angle of elevation is now 10 degree. See, I have drawn quite rough drawing. This drawing you can redraw it to make it look better, right? Once the rough drawing is done, draw it little better. Tower B, from tower B we have two angles, so this will be the one and this will be the other, O2, O1. This one is 60 degree and this one is 40 degree. Then for the tower A we have, so this is the tower A. We have this one angle as 30 degree. This is the tower A, and this another angle will have make it 10 degree. Both the diagrams you can draw separately also. You can identify the right angle triangles. This is one, this is one. So you will have one, one, two, three, and four right angle triangles. If you want to label it, let's say P and Q, and let's say this is R and this is S. So triangle O2RQ, right? R is a right angle, then O1RQ. This is another right angle triangle. Then we have O2, yes, and O1. Then we have O1SP, triangle O1S and P, and O2S and P. O2S and P, this is another right angle triangle. So this is how you can construct the situation and find the related distances or whatever asked in the question. Hope you have understood the sums.